In this math lesson, we're going to learn a very important topic in mathematics. This topic appears on everyday aspect of our life, and that's what we call probability. So one will be wondering what probability is. You can say that probability is the likelihood of a desired event happening. And that's what we call probability. You can talk about the probability or the likelihood or the possibility of a pregnant woman giving birth to a male child. One can also talk about the probability, or you can say the likelihood of it raining today. These are likelihoods. These are possibilities. These are probabilities. And the desired event in this kind of situation, the desired outcome, could be giving birth to a male child, or you talk about raining today. This is what we call probability. There are basically two methods of finding probability. One of them is the experimental probability. The other one is a theoretical probability. But in this lesson, we'll be paying attention to the experimental probability. Then, we talk about the method or the formula defining this experimental probability. But before we talk about this formula, the question is this: what do we mean by experimental probability? This is a situation where experiments are carried out and we record the required outcomes or the successes against the total possible outcomes. And from the observations of this experiment, we can use it to make a prediction. So based on the experiment or based on the observations of the experiment, you can make a prediction. So this kind of prediction you make is a probability, and this kind of probability is what you refer as the experimental probability, simply because your prediction is based on the observations of the experiment. So now, how do we define this experimental probability mathematically? We say it is the number of required outcome. Somebody might even call it desired outcome. So let's say number of required outcome. So it could be outcome, could be outcomes, depending what you are doing here, over the number of possible outcomes. So number of, let's say, all possible outcomes. The number of all possible outcomes. So now, this will be the formula for calculating experimental probability. But in fact, even when we go further, we see that this formula is the formula for defining probability generally, whether it is experimental or theoretical. Now, having said this, now we can also define probability or this experimental probability using the definition of set. For instance, if you allow X, this is a set X, and this set X, we call it the success set. You know what I mean by a success set. For instance, when we talked about the probability of a pregnant woman giving birth to a male child, you see that that male child is what we refer as a success. It's like our success set. Giving birth to a female becomes a failure set. So your desired or your required outcome is what you regard more or less as a success set. So S is a success set. That is the probability you are interested in, or what you are looking out for. Then we can now say allow P of S. So when we now say P of S, this P of S is the probability of the event S happening. So now how do we define this? This will be equal to the number. This is the number of elements in the set S. So this becomes the cardinality. If you remember, we talked about the cardinality of a set N. So N means the cardinality of the set S. That is the number of elements in the set S now divided by the cardinality of the universal set. So divided by N of the universal set. So we use mu, the sign mu, to represent the universal set. So here we talked about the number of elements in the set, or divided by the number of elements in the universal set. Then remember that this mu is the universal set. So this is the universal set. At times we call it the sample space. So in probability, the universal set, we call it the sample space. Some people may even decide to call it event space. They're all the same. So the universal set, which is serving as the number of all possible outcomes. When you are using the notion of set to define it, you can call it the universal set, or you can call it the sample space, or you can call it the event space. So now, using the notion of set, one can define probability with this formula. So it is the number of elements in the set S, that is the desired set. That's what we call the success set. Now divided by the number of elements in the universal set, which we otherwise call the sample space or the event space. So in the next video now, we'll be looking at official examples to illustrate what we have said so far. Now, in this example, we are told that a die is rolled 100 times. The outcomes obtained are shown in the table below. Remember that a die is like a cube, and remember that a cube has 6 faces. So remember a die. So a die has 6 faces. You know, when you're playing Ludo, you roll your die. So each of the faces has a number there, numbered from 1 to 6. So when you roll a die, you can either have a phase 1, or phase 2, or phase 3, or phase 4, or phase 5, or phase 6. So now, when that die is rolled 100 times, phase 1 appeared 13 times. So here you're looking at the number, and you're looking at the number of outcome. Then look at the number 2, that is the phase 2. It appeared 10 times. Look at the phase 3, it appeared 15 times. Look at phase 4, it appeared 20 times. Then look at phase 5, it appeared 17 times. And finally, phase 6 appeared 25 times. And if you sum up here, that is the number of appearances, that is 13 plus 10 plus 15 plus 20 plus 17 plus 25. This will correspond to that 100 times the die is rolled. Now, the question is this: find the probability of obtaining 2. That is the probability of obtaining the phase 2. Then, let's first of all observe that this is a kind of experimental probability. How is it an experiment? You are rolling a die 100 times. Remember, when you talk about experiments, you are performing something several times. And each of the time, you record your observation. And when you are recording the observation, the outcome you want, so that particular thing you want to observe, the behavior or the number of appearances, becomes a kind of your success. And the other one you didn't want, could be your failure. So now, if I want to find this, then I can say the probability of obtaining a number 2. So this 2 is like my success set, which in this case will be a singleton of this form. Becomes a singleton. So this probability of finding 2. So I'm using the notion of set to define it. Then here is the number of elements in that set. So let's say the number of elements of 2 over the number of elements, that is the number of the event space. So we can talk about the universal set. That is the number of elements in the universal set. What will be the universal set? That is the possible outcome. The total possible outcome is this 100 times you roll the die. So now, you look at the set 2. Any of 2 means the number of occurrence of 2. So how many times, look at the number 2, how many times did it appear? 2 appeared 10 times. So this becomes the number of appearance of 2 is 10. Then the universal set is 100. That is the cardinality. The number of elements in the universal set is 100. That is if you count them. So this gives you 100. So this becomes 10 over 100. And this gives you 1 over 10. What have we done? You see, I am doing a prediction. I'm using the fact that I have seen that 2 appeared 10 times in my observation. Because when I rolled a die, I was recording the number of times each of the faces appeared. So now, I observed that the phase 2 appeared 10 times. So if you now ask me, the probability, if I roll another die, what will be the probability of obtaining the phase 2? So the probability is based on my previous observation. So I'll use this number of times it appeared when I rolled 100 times, which is 10, over the total number of occurrence, which I now have as 10 over 100, which is 1 over 10. So this is an experimental kind of probability. So I have 1 over 10, So if you want, the choice is yours. You can leave it in fraction or you can leave it in decimal. So it can either be in fraction or in decimal. So this is the A part. So the B part, we talk about the probability of obtaining 4, the phase 4. So probability of obtaining 4 is the number of elements, or that is the number of times 4 appeared over the total number of appearances. So this will give us 4 appeared how many times? This number appeared 20 times. So this is 20 over the total number of appearance, which is 100. And if you do this now, this will give us 1 over 5, which is the same thing as 0.2 if you want to leave it in decimal. Then we go to C part. We want to see the phase 6. So probability of getting phase 6 is the number of occurrence of phase 6 over the total number of occurrences, or the possible outcomes. The number of possible outcomes. So the number of occurrence of 6 is 25. Then over the total number of occurrence, which is 100, this will give us 1 over 4. And this will give us 0.25. Then here 1 over 4 is 0.5. So these are the probabilities. The probability of getting the phase 2 is 0.1. The probability of getting phase 4 is 0.2. And finally, probability of getting the phase 6 is 0.25.